Welcome to the Albany Graphite Deposit, a truly one-of-a-kind graphite resource in the world. The deposit contains a very high-purity carbon, which is leading to the innovation of next-generation graphene-infused clean technology and materials. Zenyatta is a proudly Canadian company based in Thunder Bay, Ontario. We're ready to serve a growing global market for high-purity graphite. Albany Graphite has a proven 1 million tons of graphitic carbon, which can easily be converted into graphene. The deposit was discovered in 2012 and is 100% owned by Zenyatta. It yields a very high purity, approximately 99.9% carbon. We are targeting markets for the next generation of batteries, fuel cells, cement additives, composite materials for the automotive and aerospace industries, and the nanomaterial composite market. The Albany Graphite Deposit is located in northeastern Ontario near the Constance Lake First Nation and the town of Hearst. The Trans-Canada Highway, the CN Railway, an all-weather road, a hydro line and gas line are all in close proximity. Zenyatta has engaged with world-class researchers and scientists and undergone rigorous testing to verify the purity of our graphite and its potential to be converted to graphene. Benchmarking tests and pilot application projects have been conducted in laboratories at the Ben Gurion University of the Negev in Israel, the Tokyo Institute of Technology in Japan, and Lakehead University here in Canada. Dr. Andrew Conley, Associate Professor of Geology at Lakehead University, has stated that Zenyatta has discovered a unique hydrothermal graphite deposit unlike any other. Graphite deposits like Albany are very rare, and to the best of my knowledge, none are currently being mined globally. Dr. Oren Regev, Department of Chemical Engineering, Ben Gurion University, has said, Zenyatta's purified graphite material was tested by our R&D team and found to convert much easier and with higher yields of graphene nanoparticles than any other natural graphite types that we have tried. And we're building partnerships with university research departments and next-generation material manufacturers to take advantage of our unique graphite. Jason Risner, Director of Business Strategy at Alliance Rubber Company, stated, Alliance has a long history of innovation, and it is vital for us to play an active role in leading-edge rubber technology that uses a disruptive nanomaterial like graphene. It is also critical that we partner with scientific leaders like Dr. Alan Dalton at Sussex and a company like Zenyatta with a special raw material graphite source located in North America. The Albany resource consists of two massive vertical graphite pipes reaching more than 200 meters below the ground. Open pit mining will enable almost 1 million tons of graphitic carbon to be extracted from the pipe formations. Graphene is truly a wonder material. It is a form of carbon made up of a single layer of carbon atoms in a hexagonal lattice. Based on earlier theoretical findings, graphene was isolated in 2004 by Andrei Guillaume and Konstantin Novoselov at the University of Manchester. The pair were awarded the Nobel Prize for Physics in 2010, quote, for groundbreaking experiments regarding the two-dimensional material graphene. In general, there are a few ways to produce graphene. Chemical vapor deposition results in a very high-quality graphene, but the process is expensive and difficult to scale up. Exfoliation of graphene results in low yields and variable quality at a much lower cost. And graphene oxide has better quality control and functionalization at a lower cost than chemical vapor deposition. Zenyatta 99.9 high-purity graphite has unique particle morphology, particle size distribution, and crystal structure. These unique characteristics enable easy conversion to graphene through a mechanical exfoliation technique and to graphene oxide by way of a modified Hummer's method. Current exfoliated graphene prices are hundreds of dollars per gram. With its wide range of beneficial properties, graphene is ideal for many applications. Graphene is strong and flexible with a tensile strength 200 times greater than steel. It is highly impermeable, not even helium can penetrate the surface. Graphene is a superconductor. Its high electrical current density and low resistance make it more conductive than copper. It's also the perfect thermal conductor at over 5,000 watts per Kelvin per meter. It conducts heat in all directions. Graphene is also a great coating material, helping to make other materials highly resistive to oxygen, moisture, and corrosion. Graphene is poised to introduce the next generation of supermaterials, with applications in batteries and fuel cells, electronics, high-temperature coatings, semiconductor technology, and additives for cement, plastics, asphalt, aluminum, rubber, steel, polymers, and ceramics. Graphene is leading the way to a new generation of advanced composite materials that are stronger, ultra-light, and conductive. A partnership with Ben-Gurion University in Israel tested the benefits of adding graphene to concrete mixtures. In 2016, the lab demonstrated faster curing times, greater strength, and reduced the amount of cement needed. The new admixture also has the potential to cut CO2 emissions during its production. Zenyatta graphite is a natural alternative to the $8 billion synthetic graphite market. Natural graphite greatly reduces carbon emissions with lower costs and more environmentally friendly purification processes. Graphene oxide membranes are currently being developed at Lakehead University in Thunder Bay, Ontario. These membranes exhibit some unique properties that may drastically improve the efficiency of desalination and water remediation. This important work is directly addressing water security priorities as identified by the World Bank. Zenyatta has partnered with Alliance Rubber Company and the University of Sussex in England to develop a new generation of rubber sensor products. Potential applications include a rubber band that fits around credit and debit cards with RFID chips to prevent hackers from remotely accessing information stored on the chips. Sussex is also working on flexible rubber graphene motion sensors that can detect very subtle motions, such as movements associated with breathing and pulse for healthcare monitors and sportswear use. The Alliance program will also focus on a rubber sensor product attached to food produce that changes color when the produce reaches a set temperature or after a certain amount of time passes since harvest. This product can also act as a barcode on produce in grocery stores. At Western University in London, Ontario, Zenyatta is engaged in a collaboration to develop an advanced plastic or polymer composite using Zenyatta-sourced graphene. The resulting polymer will be used anywhere lightweight materials with added strength, electrical, and thermal properties are wanted. Zenyatta 99.9 purity graphite has several competitive advantages. Our graphite is a unique material with high performance properties. The deposit is environmentally benign with a low emissions purification process. Zenyatta graphite has an advantageous cost-to-benefit ratio. Our deposit is large, with high quality and consistency. The deposit is also in a politically stable jurisdiction. Zenyatta's discovery of high-purity graphite is a game-changer to every modern industry, from vehicles and construction to nanotechnology. We're always seeking partnership with scientists and innovators to pave the way for new graphene-based technologies. Through scientific discovery and strategic applications, we're helping to build a more efficient, stronger, healthier, and sustainable future for all.